In this video, we have sort of the culmination of similarity right triangle standard number 8. The last thing we have is to completely solve a right triangle. Basically, completely solving is going to be very, very similar to the things that we've already been doing. We have a right triangle for our trigonometry. We have pieces that are given to us. In some of our earlier problems, we've had pieces that were like, here's a picture, find the value of x. Or find the value of y. Or find the value of an angle. Or find something. But for most of the problems, you were asked to find only one thing. This is different in that you have to give me everything. I want to know everything about this triangle. All 3 legs lengths, all 3 angle sizes. Of course, a lot of it is already given to us. We're told this is a 27-degree angle. We are told this is a 90-degree angle. We're told that this is a 412-meter side length. After being given all of this information, there is enough there that we can figure out the other sides and the other angles. And basically, do it any way you want. Pick a strategy that works. Sine, cosine, tangent, Pythagorean Theorem, the fact that angles add up to 180. We don't care which one you do first, but we need to know everything. So pick a strategy that gets you each of the different pieces. Starting with this one, what do you see first? Okay, Rochelle gave me angles, so based on the angles, what would you do? In order to get the angle theta, we know that the 3 angles have to add up to 180, so we can add the 2 pieces we have, giving us 117, and we can subtract those off of 180, giving us 63 degrees. This is one valid way to get it, and that's one of the 3 pieces. What else could we do? What other pieces available? Okay, so Josh decided we're going to go after x. Well, if we're going to try to figure out x, we need to set up an equation. Sine, cosine, tangent, Pythagorean Theorem. Pick one that you can set up and go with it. So what do you see that would work? Cosine of what? Cosine of 27 degrees equals adjacent over hypotenuse. And now we have to solve this equation. And so we've seen before that we'd be able to set up a proportion, cross multiply, telling us x times the cosine of 27 degrees equals 412. And with this piece of division, we get precisely what we'd have to type into our calculator. X is equal to 412 divided by the cosine of 27 degrees. And after doing that, Rochelle told me that this is 15.3. And I'm looking at that and saying, absolutely not. This is 412. You mean to tell me that's 15? No way. There's no way that this is 15.3. Looking at the calculator that you're using, that one does not follow order of operations, and so it's going to run into some big problems that way. So this one winds up with 412 divided by the cosine. Ethan, you said it's 462.39, so rounding to the nearest tenth, 462.4 meters. And now we know that one. Okay, so x equals 462.4. We still need one last piece. How are we going to get y? Yeah, we could use Pythagorean Theorem. completely valid technique. So we would have leg squared plus leg squared equals hypotenuse squared. More generally then, y squared equals 462.4 squared minus 412 squared. And when we take the square root, we'd have something that we could put into our TI calculators, typing it up so that it looks exactly like this. We can save ourselves some of the writing and the number crunching. And when we do that, what do we wind up getting? We see that we get 209.9. And so there we go. Y is equal to 209.9 meters. And we have our results. This is completely solving. Basically then, all completely solving is a combination of 3 problems. In your earlier homeworks, this would have been split up as problem number 1, problem number 2, and problem number 3. Instead, they just take those 3 pieces and say, here's one picture with 3 things to figure out. Figure out those 3 things. And you can choose. I'll note my class earlier today chose not to use Pythagorean Theorem here. Instead of using Pythagorean Theorem, they looked at the problem and said, well, if I want y and 27 degrees and this piece, that's opposite and adjacent, they chose to set up tangent instead. Still get a correct answer. We know that we'll round our answers to the nearest tenth, so there is more than one correct way to do it. They just chose tangent. You guys chose Pythagorean Theorem. It's a completely valid strategy, though. Pick which way. As long as you pick something that works, you're good to go. For this problem, where would you start? Okay, Josh chose to find the other leg. And in order to do that, we don't have other angles. So we'll have Pythagorean Theorem. If we choose to do this first, we have to use Pythagorean Theorem. If we chose to figure out an angle first, then use the angle and come back and do trig. Well, for this one, okay, so the question was raised, how would we get the angle? Well, please notice, if we're trying to figure out angle D, 7 is adjacent, 18 is hypotenuse, and so we could build it and say cosine of angle D is adjacent over hypotenuse. And it's going back about a week, but we had a whole homework on this. What would we have to do to get the variable D, to get that angle D isolated? Yeah, we have to take the cosine inverse. To get rid of cosine, we have to pair it with cosine inverse. Those cancel, and we get D is equal to cosine inverse 7 divided by 18. And so cosine inverse 7 over 18 gives us a 67.1 degree angle. Okay, we got that part now. The measure of angle D is 67.1 degrees, rounding to the nearest tenth. Well, we could use this now if we'd like. If we wanted to avoid the Pythagorean theorem, let's just say you don't like doing Pythagorean theorem, okay, well, we could go and figure out this side then by saying the sine of 67.1 degrees equals opposite over hypotenuse. We can take the information we have and then go from there. For this problem, we'd then have x equals 18 multiplied by the sine of 67.1 degrees. Please keep in mind, though, This was not a perfect 67.1 degrees. It was 67.11 and more. So if we wanted to keep this as an exact answer as we could say the sine of that, and then the second piece we had to do was to multiply by 18. So sine of the angle multiplied by 18, and this, by using our calculator and highlighting the answer that we had before, we just get greater accuracy. 16.58. So rounding off, it would be 16.6. I'd like to show you, what if we didn't do that? What if we just typed in 67.1 times 18? We would have got a rounded answer. And so we can see we're a little bit off, but was it that big of a deal? No. When we choose to round to the nearest tenth, although we're off a little bit, do you care about being off that much? For us, only wanting to be accurate to one decimal place, it's not a problem. If we needed more accuracy, then it would be an issue. Anyhow, we then say x equals 16.6. And the last thing we needed, how big is angle G? Well, we do know that angle G and angle D, those are complementary. Those two angles add up to 90. So another way we could do it is to simply subtract off the angle we have from 90. And we'd get 22.9. So 22.9 degrees. And we're done. Each of these two examples show us basically just look at the problem, find one thing. Start by looking at the problem and find one thing that you can figure out and get it. Look back at the problem and find another thing that you can get and get it. Every time you figure out a piece of information, it gives you more tools that you can then use. It gives you more options for how to get the other ones. Ultimately, you need to figure them all out so that we know every single side and every single angle. That's what it means to completely solve a triangle. Figure out all the sides and all the angles.